Hello dear students, welcome to a whole new session. In this session, we will be learning the chapter Surface Areas and Volumes. You all have studied that in grade 9, except that we have a little additions and modifications in this chapter, a little bit of new topics. Before we begin, let's have a look at the key concepts that we will be discussing in this chapter. We will be learning about three basic parameters, namely lateral or curved surface area, secondly total surface area, and thirdly volume of 7 different solids. Let's begin. Here comes the first solid, a cube. What is a cube? A cube is a solid that is made of 6 identical squares. By identical squares, we mean that the dimensions of the squares are the same. Now, lateral surface area means the area that we can see when we are observing a solid from the sides. Neither top nor bottom, only the sides. So, what can we see when we look at a cube from the sides? We can see 4 identical squares. Now, let's say side of one square is S. So, the area of that square will be S square, right? Now, 4 such squares are seen. So, the lateral surface area of a cube is given by the equation 4 into S square. That's right. Now, to find total surface area of any solid, all you have to do is add the lateral surface area and the top base area and the bottom base area. For a cube, both top and bottom are again squares with side S. So, we can say that the total surface area of a square is given by 6 into S square. Moving on to volume. Volume of a cube is given using the equation A cube. Now, before moving on to the next solid, I would like to make a note of the equation that gives a relation between volume of a solid and its area. Volume of a solid is equal to area into height of the solid. So, let's talk about the cube again. What is the volume of a cube? A cube. How did we get that? Let's talk about the base area of a cube. What is the base area of a cube? That is a square. So, base area will be side into side or side square. Now, what is the height of a cube? Again, a side or S. So, we are multiplying S 3 times. That's how we get S cube. You will understand that equation in detail when we talk about the other solids as well. Now, let's move to the second solid, that is a cuboid. Now, cuboid is another 6-faced solid, except that it is made entirely of rectangles. Let's say a cuboid have a length, breadth and height. Let length be denoted using L, let breadth be B and height be H. Then the lateral surface area that we can see from the sides will be given as 2H into L plus B. That's how we get. Now, for total surface area, we have to add the top and the bottom. So, the final equation for total surface area of a cuboid will be 2 into LB plus BH plus HL. I hope it's clear. Now, volume. What did I talk about the volume? Volume is equal to area into height. What is the base area of a cuboid? That is L into B. So, L into B into H is equal to volume of a cuboid, or volume is equal to LBH. Now comes the third solid, that is a hemisphere. It looks like a bowl or a coconut shell. Now, the only dimension of a hemisphere is radius or diameter. Anyway, both are the same. Now, for curved surface area of a hemisphere, the equation is 2 pi r square. Now, the total surface area of a hemisphere is given by the equation 2 pi r square plus the base, and the base is in the shape of a circle again. So, there comes 2 pi r square plus pi r square. So, that will give you 3 pi r square. Talking about the volume, the equation for volume of a hemisphere is equal to 2 by 3 pi into r cube. We'll go to the next solid now, that is a sphere. A sphere is constructed with nothing but two hemispheres. And when we talk about a sphere, it doesn't have two types of surface areas, because from whichever point we observe a sphere, it's of the same shape. So we can say surface area, neither curved surface nor total surface area, just surface area of a sphere. Now, what is the surface area of a hemisphere alone? That is 2 pi r square. Now we need one more hemisphere to make it a square. So that is 2 into 2 pi r square or 4 pi r square. That's right. Now for volume of a sphere, that is again 2 into volume of one hemisphere. So what is volume of one hemisphere? 2 by 3 pi r cube. So volume of one whole sphere will be 2 into 2 by 3 pi r cube or 4 by 3 pi r cube. Here comes the next solid, a cylinder. We all know what a cylinder looks like. It has a height and a radius. Let's move on to the curved surface area of a cylinder. So for that, we can imagine looking through a hollow pipe. What can you see? We can see through it. And what will be the area of the material required to make that sheet or to make that cylinder? Apologies. So we have a circumference and we need some height. Is that clear? When we are looking through a cylindrical pipe, we can see it in a round shape with a circumference, and we can hold it up to a height or a length. So there is circumference and height. When we combine it together, that becomes 2 pi r into h, where 2 pi r is the circumference and h is the height. So that's how we get the curved surface area of a cylinder. So CSA of a cylinder is equal to 2 pi r h. Now for total surface area, again, all you have to do is add the top and bottom bases. Now we know that both top and bottom bases of a cylinder are circular. So area of a circle is pi r square and twice it. So 2 pi r square. Now you may add it to the curved surface area. So the total surface area of a cylinder is given by 2 pi r h, that is the curved surface area, plus 2 pi r square. You can simplify that equation to reduce it into a much simplified form. Now coming to the volume of a cylinder, volume is again area into height. Now the base area is circular, so area of a circle is pi r square and height is h. So pi r square h is how we get the volume of a cylinder. Then comes the solid, a cone. A cone has radius, height and one more parameter, that is called the slant height. That looks like this. Name suggests it's slant height. Now to derive slant height, we may observe the cone in the form of an isosceles triangle with height h and base r, and on one side of the isosceles triangle, when we apply Pythagoras theorem, we will get the slant height. So L square can be written as h square plus r square, or L is equal to root of h square plus r square. That is the equation for L. In the questions, they will be given only h and r, not L in most times. So L is equal to square root of r square plus h square. Now talking about the CSA, we will have to integrate this slant height. So the equation for CSA of a cone is equal to pi into r into L, where r is the radius, L is the slant height. Now for TSA, all we have to do is add the base area. So that will be pi RL plus pi r square, only one circular base. For volume of a cone, you can study that with connecting it with cylinder. We know that a cylinder volume is equal to pi r square h. Now when it comes to a cone, the equation is 1 by 3 of pi r square h. So the equation is same. All you have to do is add or multiply the 1 by 3. Now we shall move to the new topic, frustum. A frustum is made by cutting out a small cone out of a bigger cone. So, similar to a cone, a frustum will have a slant height L and a height H. But unlike a cone, a frustum will have two circular bases of different radius. So, let's say R1 be the radius of the bigger circle and R2 be the radius of the smaller circle. Then, the slant height of the frustum can be given by the equation square root of R1 minus R2 the whole square plus H square. Now, talking about the curved surface area of a frustum, the equation is pi into R1 plus R2 into L, that is slant height. For total surface area of a frustum, the equation is pi L into R1 plus R2, that is a CSA, plus the top base, that is or the bigger base, that is pi R1 square plus pi R2 square, that is a smaller base area. To find the volume of a frustum, the equation is 1 by 3 pi H into R1 square plus R2 square plus R1 R2. Now, let's have a look at the pictorial representation of the formation of a frustum. You can see in the extreme left side, there is a big cone and the cone is being cut. After the cutting, we will get the frustum. Let small letter h be height of the frustum, L be the slant height of frustum, R1 be radius of the bigger base and R2 be radius of the smaller base. As you can see from the figure, let's take two triangles, triangle VBA and triangle VQP. In these triangles, angle B and angle Q are 90 degree each and angle V is a common angle. So, using AA criterion, we can say that the triangles are similar. Now, let's make use of the CBSE condition. So, by CBSE, VB by VQ will be equal to BA by QB and that is equal to VA by VP. We may substitute for these sides from the figure. So, the equation will be capital H by capital H minus small letter h, that is equal to R1 by R2, that is equal to capital L by capital L minus small letter l. By taking reciprocal and rearranging, the equation can be rewritten as 1 minus small letter h by capital H is equal to R2 by R1 is equal to 1 minus small letter l by capital L. Now, let's take the first two parts of this equation, that is 1 minus small letter h by capital H is equal to R2 minus R1. Upon simplifying, we can form the final equation for capital H, that is equal to small letter h into R1 by R1 minus R2. Similarly, the equation for capital L can be formulated as small letter l into R1 by R1 minus R2. Now, we may deal with the derivation of volume of frustum. We know that a frustum is being made by taking out a small cone out of a big cone. So, volume of frustum is equal to volume of the bigger cone minus volume of the smaller cone. We can replace these with equations as 1 by 3 pi R1 square into capital H minus 1 by 3 pi R2 square into capital H minus small letter h. Now, you may open the brackets and simplify. We will get 1 by 3 pi small letter h R1 by R1 minus R2 into R1 square minus R2 square plus 1 by 3 pi R2 square into small letter h. Now, you may notice that R1 square minus R2 square is of the form a square minus b square. That is the identity. So, a square minus b square is equal to a minus b into a plus b. Similarly, R1 square minus R2 square can be replaced with R1 minus R2 into R1 plus R2. Now, you may cancel R1 minus R2 from both numerator and denominator, and what's left with us? the final equation for volume of a frustum. That is 1 by 3 pi h into R1 square plus R2 square plus R1 R2. Now we shall move to the derivation of curved surface area of a frustum. Again, curved surface area or CSA of a frustum can be given as CSA of the big cone minus CSA of the small cone. So, CSA of the big cone is pi into R1 into capital L minus pi into R2 into capital L minus small letter l. Upon simplifying, we will get pi L into R1 plus R2. Again, we have to apply R1 square minus R2 square is equal to R1 minus R2 into R1 plus R2, the identity. Now the total surface area is very simple. All you have to do is add the base areas to the CSA. So we will get pi into L into R1 plus R2, that is a CSA, plus the bigger base area, that is pi R1 square plus smaller base area pi R2 square. Now we shall move to the numericals or the problems. So there are similar type of problems, there are many types of problems in this chapter. So the first type that we will be dealing with is area of combination of solids. In these type of numericals, more than one solids are combined together and the area or volume of these solids, resulting solids, will be asked to find. So question number 1. A decorative block shown in figure is made of two solids, a cube surmounted by a hemisphere. The base of the block of the cube is 5 cm and hemisphere fixed on top has a diameter 4.2 cm. Find total surface area of the block taking pi is equal to 22 by 7. Now let's have a look at the figure given here. It shows the different perspectives of observation for this given block. So the first figure shows the lateral view of the given block. The second figure shows the bottom view and the third one is the top view, which is very important. So the total surface area of the block is to be integrated with all these three perspectives. So the TSA of the entire block will be given as LSA of the cube plus CSA of the hemisphere, that is the lateral view, plus lower base of the cube, that is a square, plus upper base of the cube minus base of the hemisphere, that is the top view. Now let's put all the equations. So that will be 4s square plus 2 pi r square plus s square minus pi r square. When we simplify these, this will be very much simplified into 6s square plus pi r square. Putting the values or the numerical values, we will be getting the final answer as 163.86 centimeter square. Let's move on to the second question. An oil funnel of tin sheet consists of a cylindrical portion 10 centimeter long attached to a frustum of a cone. If the total height is 22 centimeter, the diameter of the cylindrical portion 8 centimeter and the diameter of the top of the funnel is 18 centimeter, find area of the tin required. It's a very direct question and the funnel is totally hollow. So all we need is the CSA of the frustum plus CSA of the cylinder. So pi L into R1 plus R2 plus 2 pi RH. Now before proceeding to the main problem, you have to find the slant height of the frustum. Using the equation, L is equal to root of R1 minus R2 the whole square plus h square. Upon putting the values, we will get the value of L as 13 centimeter. Now area of the tin required is equal to pi L into R1 plus R2 plus 2 pi RH. Putting all the values, we will get the final answer as 275.57 centimeter square. Let's move on to the next question. A circus tent is cylindrical to a height of 8 meter surrounded by a conical part. If total height of the tent is 13 meter and diameter of its base is 24 meter, calculate area of the canvas required to make this tent, allowing 10% of the canvas used for foldings and stitching. You can see the figure on the extreme right side and all the parameters had been marked there. Now we have given that the total height of the tent is 13 meter and height of the cylindrical part is 8 meter. From that data we can find the height of the cone, that is the remaining height. So height of the cone will be 13 minus 8 is equal to 5 meter. Now we are supposed to find the total area of the canvas required, but there is a condition. 10% of the total canvas is to be used for folds and stitching. So the equation will be total canvas is equal to canvas for tent plus 10% for total canvas. As in canvas for tent is for the shelter and 10% of the 10% of the total canvas is for all the decorations. So we have to rearrange the equation by bringing on the 10% of total canvas to the other side. So that becomes total canvas minus 10% of total canvas is equal to canvas for tent, or simplifying we will get the equation as total canvas is equal to canvas for tent into 10 by 9. Before moving on to the numericals, let's find out the slant height of the conical part. L is equal to root of r square plus h square. Equating all the values, we will get L is equal to 13 meter. Now the canvas for tent can be written in equation form, in mathematical form, as pi rl plus 2 pi rh. That is equal to 22 by 7 into 12 into 13 plus 2 into 22 by 7 into 12 into 8. The answer will be 1093.71 meter square. Now the total canvas is 10 by 9 of what we get for canvas for tent. So 1093.71 into 10 by 9, that is equal to 1215.23 meter square. I'll repeat, 1215.23 meter square is the total canvas that is required. Moving on to the fourth question. A vessel is in the form of a hollow hemisphere mounted by a cylinder. The diameter of the hemisphere is 14 centimeter and total height of the vessel is 13 centimeter. Find the inner surface area of the vessel. Again, the given data is total height of the vessel and height of the hemisphere. When we say about hemisphere, both height and radius are the same. So from that data, we can find height of the cylinder, that is 13 minus 7 is equal to 6 centimeter. So again, it's a direct question. So surface area of the vessel will be CSA of cylinder plus CSA of hemisphere. That is equal to 2 pi RH plus 2 pi R square. Substituting the values, the final answer will be 572 centimeter square. Let's go to the fifth question now. A wooden article was made by scooping out a hemisphere from each ends of a solid cylinder as shown in the figure. If the height of the cylinder is 10 centimeter and its base is of radius 3.5 centimeter, find the total surface area of the article. As you can see in the figure, in this question, the hemispheres are being taken out of the cylinder. That's new, right? We had been dealing with solids formed by combining more than one solids. But don't worry, to find area of such solids, all you have to do is observe the whole solid from different sides and combine using equations. So the equation combining is simple here. You can see a cylinder and two hemispheres. So the equation for the total surface area of this solid is equal to CSA of cylinder plus CSA of two hemispheres. Now two hemispheres will make one circle, so you can replace it with CSA of a cylinder, that is 2 pi RH plus 2 into 2 pi R square, or equivalently 4 pi R square. Now substituting the values, we will be getting the final answer as 374 centimeter square. Now let's talk about the volumes in these cases. Cases as in combination of solids. Unlike area, all you have to do is, if two solids are combined to form a new solid, then you have to add the volumes. And if one solid is being taken out of the other one, you have to subtract the volumes. So we can simply apply it to the concept that is given. Let's move on to the first question. A spherical glass vessel has a cylindrical neck 8 cm long, 2 cm in diameter. The diameter of the spherical part is 8.5 cm. By measuring the amount of water it holds, a child finds its volume to be 345 cm cube. Check whether she is correct, taking the above as the inside measurements, and pi is equal to 3.14. They had specifically given the value for pi. Like I said earlier, all you have to do is apply the words into mathematical solutions. So clearly there is a cylinder and a sphere. So all you have to do is add the volume of sphere and the volume of cylinder. So volume of sphere is equal to 4 by 3 pi r cube, and volume of cylinder is given by pi r square h. So the answer that we get is 346.51 centimeter cube, but the child in the question got it as 345. So clearly her answer is wrong. Now we shall go to the second question. Now this is a very important and very frequently asked question, especially in the final section of your question paper. Let's read the question. A gulab jamun contains sugar syrup up to 30% of its volume. Find approximately how much syrup is to be found in 45 gulab jamuns, each shaped like a cylinder with two hemispherical ends with a length 5 cm and diameter 2.8 cm as shown in the figure. I hope you can see it from the figure. We have marked all the dimensions. So the total length of the gulab jamun is 5 cm, and there are two hemispheres attached to the both ends, to the either ends of the cylinder. So to find height of the cylinder, you have to subtract the two radii of the hemispheres from the total length. That is 5 minus 2.8 will give you 2.2 centimeter. That will be the height of the cylinder. Now we have to find the amount of syrup, right? So it's given that amount of syrup in one gulab jamun is equal to 30% of its volume. And we are supposed to find amount of syrup in 45 such gulab jamuns. So amount in 45 gulab jamuns is given by 45 multiplied by 30% volume of one jamun. Now we'll do it part by part. Let's first find volume of one gulab jamun. Now the shape of gulab jamun is cylinder plus two hemispheres. So we can add them. So that will be pi r square h plus 2 into 2 by 3 pi r cube. So the answer will be 25.052 centimeter cube. That is the volume of one gulab jamun. Now amount of syrup in 45 gulab jamuns will be 45 into 30% of one gulab jamun's volume. So that will be equation 45 into 30 by 100, that is 30%. So 30 by 100 into whatever we got as volume of one gulab jamun, that is 25.052. So the final answer will be 338.25 centimeter cube. So that is the amount of syrup in 45 gulab jamuns. So we had found the answer for that one. Let us go to the next question, the third question. A juice seller was serving his customers using glass. The inner diameter of the cylindrical glass was 5 centimeter, but the bottom of the glass had a hemispherical raised portion which reduced the capacity of the glass. If height of the glass was 10 centimeter, find the apparent capacity and actual capacity. Now the glass is ideally of the form cylinder with a hemispherical raised portion, but the apparent capacity means the capacity of the glass if it was just the cylinder. So apparent capacity can be given using the equation pi r square h. that is the volume of the cylinder. So pi r square h will give you 196.25 centimeter cube. Now to find the actual capacity, all we have to do is subtract the volume of the hemisphere from the volume of the cylinder, or the apparent capacity minus volume of hemisphere. That is equal to 196.25 minus 2 by 3 pi r cube. Solving it, we will get the actual capacity as 163.54 centimeter cube. So as you can see, the apparent capacity is bigger than the actual capacity. So yes, it has actually reduced the capacity of the glass. The next type of questions that can be asked for exam is liquid level change. For example, there will be a liquid in a container and we will be dipping or immersing another solid in that liquid. So by Archimedes' principle, the volume of the object immersed will be equal to the volume of the water that is being displaced. So that is a principle that we are applying to do these types of problems. So let's move on to the first problem. 500 persons are taking a dip into a cuboidal pond which is 80 meter long and 50 meter broad. What is the rise of the water level in the pond if the average displacement of the water by one person is 0.04 meter cube? So let the water level rise be h. Why? Because let the pond be of water level this much, and after 500% taking a dip into the pond, let the water level rise by this much. So this gap is what we have to find. And by Archimedes' principle, the volume of the object immersed will be equal to the volume of the water that is being raised. So what is the object that is being dipped? The object here is 500 persons. So the left hand side will be volume of object, that is volume of 500 persons, that is equal to, and what is the shape of the pond, that is a cuboid. So volume of 500 persons is equal to volume of cuboid. What is the equation for volume of a cuboid? L into B into H. I hope you remember the equations. So let's directly substitute the values. For 500 persons, it is 500 into 0.04. Why? Because in the question, it is given that the average displacement for water by one person is 0.04. For one person, it's 0.04. For two persons, it will be 2 into 0.04. Then for 500 persons, it would be 500 into 0.04. So 500 into 0.04 is equal to, what is L? 80 meter. What is B? 50 meter. And H is what we have to find. So 80 into 50 into H. Upon cancellation and transposing, we will get the value of H as 0.005 meter, or we can convert it into centimeter, and that will be 0.5 centimeter. So when 500 persons are jumping into a pond, the water level rises a mere 0.5 centimeter. Fascinating, right? Let's have a look at the next question type, change of shape. For example, a candle which is initially of the shape a cylinder, even after melting, after completely burning out and melting and deforming it into some other shape, the amount of wax used in the candle will remain constant. So that is a key point that you have to remember in change of shape type of questions. Even if a substance change its shape from one form to another, the volume of the amount of substance will remain constant. Mathematically, volume of shape 1 will be equal to volume of shape 2 after reshaping. Let's move to the first question. How many spherical balls, each of radius 1 centimeter, can be made from a solid sphere of lead of radius 8 centimeter? So in this case, a huge sphere of radius 8 centimeter is to be reshaped into several small spheres of radius 1 centimeter. And we are supposed to find the number of that many spheres. So let's take the number be n. So n into volume of small balls is equal to volume of the big sphere. So the bowl and sphere are spherical. So the equation will be n into 4 by 3 pi small letter r cube is equal to 4 by 3 pi capital R cube. Why have I taken small r and capital R? Because they are both spheres and the radii are different. So 4 by 3 pi and 4 by 3 pi are common on both sides. So they can be cancelled then and there. Now what's remaining? N into small letter r cube is equal to capital R cube. Now capital R is 8, small r is 1. So n into 1 cube is equal to 8 cube, or n is equal to 8 cube. What is cube of 8? That is 512. Therefore, 512 mini spheres or bowls can be made from the huge sphere. To conclude, moving on to the second question, let's read the question. Water is flowing at the rate of 15 km per hour through a pipe of diameter 14 centimeter into a rectangular tank which is 50 meter long and 44 meter wide. Find the time in which the level of water in the tank will rise by 21 centimeter. For simplicity, we had shown the illustrations here and marked the dimensions. So there is a pipe which is cylindrical in shape, so there is a cylinder, and there is a cuboidal tank. Now the dimensions are, the height or the length of the pipe is not given, so we had taken it as h itself. Now they are given it as 15 km, then 14 centimeter. The dimensions, the units are different, so we have to make them into one single unit. So we had decided to convert everything into meter. So 14 centimeter diameter had been converted to meter and is 0.14 meter. Now for the cuboid, the length is 50 meter, width or breadth is 44 meter, and we will take the height as 21 centimeter or 0.21 meter, because only that height is the water level rising. Again, the shape is changing. Even if the water is flowing, the shape is changing from cylindrical to cuboidal. So volume of pipe, that is a cylinder, is equal to volume of tank, that is a cuboid. So volume of pipe is pi r square h is equal to L into B into H. Substituting the values, we will get the value of H, that is the length of the cylinder, as 30 kilometer or 30,000 meter. After conversion, we will get as 30 kilometer. Now we are not asked to find the length of the pipe. The question is to find the duration to take for the water level to rise by 21 centimeter. So the speed of the water flow has been given. What is the rate of water flow? 15 kilometer in 1 hour. We are supposed to find how many hours does it take to cover 30 kilometer, that is a height. So we have to do the cross multiplication and division. So 15 kilometer in 1 hour and 30 kilometer in x hour. Let x be the time duration. So after cross multiplying, we will get the time for rising the water level by 21 centimeter as 30 into 1 divided by 15. That is equal to 2 hours. So it takes 2 hours to fill 21 centimeter in the cuboidal tank. Now let's move on to the questions related to frustum in real life. Now only for frustum type of questions, there won't be any combination concept, so we can directly apply the equations. Let's go to the question. A bucket open at the top is in the form of a frustum of a cone with a capacity of 12,308.8 centimeter cube. The radii of the top and bottom circular ends are 20 centimeter and 12 centimeter respectively. Find height of the bucket and the area of metal sheet used in making the bucket. So lot of data is being given and we have to find two parameters. First thing is the height of the bucket, that is unknown, and the area of sheet required to make the bucket. So let's begin. First of all, list out whatever data is being given. So we are provided with the volume of the frustum. So volume of the frustum is given, the value is given. So we will begin with that equation. What is the equation for volume of a frustum? 1 by 3 pi h into R1 square plus R2 square plus R1 R2. With that, we can find height of the frustum as 820.587 into h. So h will be equal to 15 centimeter upon simplification. Now let's find the area of sheet required. The area of sheet required is not just CSA because it's a bucket, it's used in real life applications. So it needs to be, it needs a base, and that base will be the smaller base. We all know how a bucket looks like. So first let's find slan height. L is equal to root of R1 minus R2 the whole square plus h square, and we will get the L, the value of slan height, as 17 centimeter. Now the total area of the sheet is equal to CSA of the bucket plus the lower base area, that is the smaller radius area. Okay, so the equation will be pi L into R1 plus R2 for the CSA plus pi R2 square, where R2 is the radius of the smaller base. Upon putting the values or all the numerical values given in the question, we can solve the equation and we will get the value of the total area of the sheet as 2160.32 centimeters square. Thank you.